Part 2, Project Earth. There's a concept in electrical engineering called the signal-to-noise ratio, which has to do with the ratio of a signal power to a noise power which corrupts the signal. It's like listening to music on your radio in a car, which is receiving a great deal of interference, and the music is becoming clouded and distorted. I think this is a great metaphor for our current social practices. The signal being the foundational aspects of importance and relevance to a given field, with the noise being the outdated, traditionalized, inefficient methods which cloud, confuse, delay, and distort our intents and abilities. So, I want everyone to forget pretty much everything I've just talked about and take a massive step back and consider a very simple thought exercise that I want to walk through in regard to how we conduct our operations on this planet. Let's assume for a moment that we are interstellar travelers originating from Earth as it is known today. And in our journey, we stumble upon, amazingly enough, an exact replica of our planet. The only difference between the current state of this new planet versus our own is that there are no human beings. Human evolution has not occurred. Hence, there's no establishment orders, no social arrogances, no money, of course, nothing to limit our possibility. Given the advanced scientific knowledge we have today, how would we go about redesigning our social infrastructure from the ground up, with the goal to create nothing less than the most efficient, conscientious, and sustainable society as possible? So, what is the first step? A full survey of Earth's natural resources would make sense, correct? I think it would be illogical to begin any other way. We must first understand the full range and capacity of the earthly components in order to derive inference as to our capabilities. Natural resources come in many classifications, such as biotic, meaning those obtained from the biosphere, such as forest, maritime organisms, and mineral fuels. And then there's abiotic, such as arable land, water, gold, iron ore, and other such raw materials. There are many natural resources to be considered, of course, but for the sake of simplicity, we're going to consider just one area, and this will serve as the prototype for all the others, and this area is energy. Energy is the fuel of society, I think most people would agree. Energy appears to be the lowest common denominator of modern civilization, and it has been the basic facilitator of progress and the expansions of our standards of living. So I think it's a good place to begin. Okay, so what do? We simply scan the Earth and analyze it, listing all relevant energy locations and potentials. Of course, the potentials, to clarify a little bit, is always going to be based on the current state of technology for harnessing. For example, solar energy today has a dramatic potential, but it is still greatly underutilized as the technology has been inefficient so far. But with the advent of nanotechnology, we are seeing a possible exponential increase in this potential. So it's contingent upon the quality of our methods, is my point. Also, I don't want to spend much time on the issue of nanotechnology, but if you research these trends as applied to solar radiation harnessing, it becomes clear that solar energy alone in time could power the entire world 1,000 times over. Unfortunately, you're not going to see this anytime soon. Why? Because it's too efficient for the market system. And the absorption process would take many, many years if seriously pursued. So, back to our original thought exercise. Once we have this raw data of energy sources, we need to rate each source based on its renewability, pollution output, and everything that factors in to decide the degree of sustainability. Those sources that have the most negative retroactions are given the least priority in utilization, of course. And by the way, this is an arbitrary chart. Don't take it too seriously, obviously. For example, fossil fuels are mostly non-renewable and can pollute the environment. Given the tremendous power of geothermal, wave, wind, and solar combined, I would say that there is absolutely no reason to even bother with fossil fuels at all. And to clarify this very quickly, I would like to run down these renewable mediums. According to a 2005 Stanford University study, if 20% of the known potential of wind energy was harnessed, it would power all the world's needs. We already mentioned solar energy. The radiation hitting the Earth's surface is about 10,000 times the planet's usage, in fact. This issue comes down to technology, nanotechnology, as we denoted. Lesser known is tidal power. As a regional example, in a recent study it has been found that 34% of all of the United Kingdom's energy could come from tidal power alone. But more effectively, as far as the ocean, is wave power, which has been found to have a global potential of 80,000 terawatt hours a year, meaning 50% of the entire planet's energy usage could come from tidal power alone. However, most effectively is geothermal energy, which, according to a recent MIT analysis, contains enough energy to meet the world's needs for the next 4,000 years. In other words, energy is nothing but abundant on this planet, and don't let anyone tell you otherwise. So, back to our exercise. Once this data is established, we compare the potentials to consumption and adjust accordingly. Fortunately, as we've just analyzed, we do have more than enough energy to meet our needs, so we can eliminate the least efficient sources, such as oil and everything else. And there we have it. We have our pool of supportive energy resources to utilize. Okay, step 3, distribution and monitoring. Energy distribution would be logically formulated based on technological possibility and proximity to sources. In other words, if we have wind energy utilized in Asia, we're not going to deliver that energy to Latin America. So distribution parameters would be self-evident based on the current state of distribution technology and proximity practicality. Likewise, active resource monitoring done through Earth sensors and computers would allow for a constant awareness of the rate of use, the rate of depletion, the rate of renewal, and any other parameter relevant to know, in order to maintain, of course, a balanced load. If the scarcity of any resource is going to occur, we can forecast this in advance through trend analysis, and proper action can be taken to adjust accordingly. This idea is nothing new. It's used every day in our lives in detached ways, such as the ink level notification on your personal printer connected to your home computer. Okay, let's review. What do we have so far? We have the locations of our energy resources. We have the output potentials and distribution qualifiers, which are based on strategic use, technological harnessing, and proximity. And finally, we have a system of active resource monitoring, which reports the state of energy supply, rates of usage, and any other relevant trends. In other words, we've created a system, a systems approach to energy management on the planet. The system is comprised of real-time data and statistics. The process of unfolding is based not on a person or group's opinion, not on the whims of a corporation or government, but on natural law and reason. In other words, once we establish the interest and goal that survival and hence sustainability is our goal as a species, which I hope everybody in this room agrees, then each parameter to consider in regard to resource management becomes completely self-evident. It is called arriving at decisions as opposed to making them, which is a subjective act based on incomplete information and very often cultural biases. The planet is a holistic system with resources all over it. Therefore, the efficiency of human society can only come from an integrated systems approach to the management of those resources and hence social processes. The planet demands it, if you will. The only government that exists is planetary operations, is natural law. It is inherently negligent, illogical, and irresponsible to function in a detached manner. We require a holistic system. Okay, using this energy model as our procedural example, this systems approach can be applied to every other earthly resource and quantifier. We survey, find potential, qualify for negative retroactions, and apply modern technology to harness, distribute, and monitor in the most logically advanced, holistic way possible. Naturally, a computer database management program would be the logical method to navigate these issues, where all the attributes we have discussed are fed in with strategic computation applied. And since the goal is holistic maximum efficiency, the automation of adjustments also becomes very simple. For example, let's say we have 2 geothermal power plants in the same region, each outputting in tandem the required amount of energy for that region. One day there's a problem, and the output of one plant drops by 30%. This would be seen by the monitoring system, and the other power plant's output would be automatically adjusted by 30%. It is reactive, just like the nervous system in your body, automatic. No reason to vote for it, no reason to debate it in Congress. It's automatic because it's self-evident. So, to summarize this approach, all planetary resources, from energy to minerals to maritime life, etc., are managed by strategically active statistical processes in a single global system which is programmed to adjust automatically to the changing environment. That's it. Correct me if I'm wrong, but I'm afraid there is no other way to achieve peak efficiency of our resource usage. It is a technical process. It's also very, very simple when you think about it, even though the specifics of implementation. So the question then becomes, what do people need? This is actually quite an elusive question. On one side of the spectrum, you have the immutable necessities of life, such as food, clean air, water, and the like. While at the other extreme, we broach issues of vanity, material tools, leisure goods, and other issues which basically vary from region to region, culture to culture, and generation to generation. This latter part regarding value-based needs will be addressed somewhat later. But for now, we're going to focus on the former, the basic necessities of life for all of us. Food and water. Naturally consumable water supplies, or fresh water, would be sourced as part of our initial global survey and regulated and monitored as we discussed. When it comes to food, the first to consider is agriculture and then hence arable land. So we survey and locate all available arable land on the planet. Then we establish consumption statistics based on the population's usage. Now, obviously, analysis would become much more complex than what I'm denoting here because there are many things to consider, such as the growth propensity for certain crops, the methods used for cultivation, the need to counter negative retroactions, and many other fine points. However, once again, each one of these issues can be isolated, recognized, and quantified to one degree or another systematically. I want to continue to address the process. That's the most important point. Now, to extend this point, the conventions used for cultivation and preservation of food and water right now only takes us so far. This is an area where technology becomes critical in light of our growing population. In society today, food and water scarcity is massive in developing nations. Here is a projection done by the IRRC regarding water scarcity by 2025. In turn, as of now, 1 billion people are starving on this planet, according to the United Nations. It's probably a lot more than that, considering how the United Nations tends to whitewash such issues if you pay attention, but nevertheless, it's still insane. And anyone who is paying attention knows that the problems of food scarcity and water scarcity is 100% economic. The technical resolution of the problem can happen with the mere application of existing methods, namely desalination and hydroponic agriculture. Technological advancements such as desalination processes can make fresh water both from seawater and even brackish water sources, using reverse osmosis along with other developing methods. This is yet another example of how technology is just as much a part of resource management as resources themselves. The idea that usable water is scarce is only true in relationship to the limited methods we are currently using, compounded, of course, by the economic nonsense we have already mentioned. The same goes for hydroponics, which is a method of growing plants using mineral nutrient solutions in water without soil. In fact, we could theoretically grow food in the middle of the Sahara Desert with proper irrigation by simply tapping down to the water table. I believe it's about half a mile to a mile down. It might sound like a long way, but again, many things that seem extreme to us today become commonplace through time. And, by the way, I hate to sound negative, but if the United Nations was truly concerned about the well-being of the third world, if they really cared at all, frankly, they would be facilitating the building of desalination plants along the coast of every suffering nation to convert ocean water to consumable, usable water, and then they would filter organic nutrients from the ocean itself into hydroponic greenhouses. That would resolve. The bottom line is that food, air, and water are only as scarce as we decide they are. If we choose to become intelligent and strategic with our production and preservation methods, While taking full advantage of technology, there is no reason why we can't provide for the Earth's people many, many times over. The starving children of the world today are not so because of a lack of available food and water. It is their lack of purchasing power, the failure of their economies, not true scarcity, which causes the needless deaths of millions a year. In the world today, one person dies of hunger every second because of poverty. Okay, back to our original exercise. These technological advances I have just spoken of, along with many others, would be coupled in with traditional methods and thus monitored and regulated in our systems approach as we have already expressed. The point is that new efficiency-increasing technologies would be quickly incorporated into the system based on qualifiers. Now, you will notice once again that choice becomes self-evident. As long as the integrity of our methods of evaluation, which is the scientific method, is strictly followed, coupled with the goal of maximum efficiency and sustainability, the process of societal construction and organization becomes almost entirely self-evident. We are arriving at decisions based on this simple goal of maximizing efficiency in whatever way we can. And this pattern of thought, this commitment to the objective observation of natural processes and loyalty to the scientific methodology utilizing hypotheses and testing, etc., leads us to part 3, with the introduction of an organization called the Venus Project. Everything that we have just talked about are the basic attributes of a social design called a resource-based economy. This term was coined by industrial designer and social engineer Jacques Fresco, who is the director of the Venus Project, which he runs with his associate Roxanne Meadows out of Venus, Florida. Mr. Fresco has been focusing on the concept of sustainability and culture for the past 70 years. He is 93 years old now. This is all he has ever done. And the majority of things you're seeing in this presentation come from his worldview. The Venus Project recognizes that the Earth is indeed abundant with resources, and that our outdated methods of rationing resources through monetary control are no longer relevant, and in fact very counterproductive to the efficiency of society and hence our survival. The monetary system was created thousands of years ago during periods of great scarcity and has no legitimate relationship to our true capacity to produce goods and services on this planet in this day and age. We know now that with a unified systems approach to global management, as we have just described, that the human species will be able to express its full potential. In fact, I will say explicitly that that is the only way you could ever maximize the efficiency of the planet and hence our usage of it, is a global systems approach. Modern developments in science and technology, as we have just discussed, can now allow for this approach to become a reality. To summarize a resource-based economy, first, it utilizes existing resources rather than commerce. All goods and services are available without the use of currency, credit, no barter, no debt, no servitude. The aim of this new social design is to not only free humanity from the repetitive, mundane, and arbitrary occupational roles, many of which hold no true relevance for social development, but also encourage a new incentive system that is focused on self-fulfillment, symbiotic awareness, education, social awareness, and creativity, as opposed to the contrived, shallow, self-centered, corruption-generating goals of wealth, property, and power, which are not only dominant today, but abhorrently actually praised by the population. The great realization of this concept is that through the intelligent management of the Earth's resources, along with the liberal application of modern technology and science, we have the ability to create a near global abundance on this planet and thus escape the detrimental consequences, both physical and psychological, generated by the real and artificial scarcity and waste which is prevalent today. The end goal isn't just about physical sustainability in and of itself, in fact. It's also about the larger goal of cultural change. The values of humanity are created by the social system, and we feel this approach will not only bring us in line with natural law, enabling a high standard of living, but will ease social stress dramatically and allow for people to flourish without the aberrated consequences we see over and over today. We're being poisoned by our social system. War, poverty, and 95% of all crime are essentially monetary related if you look carefully. The Venus Project recognizes this, and if we can adapt to this new approach, I think we can completely eliminate these issues. So, to further understand this resource-based economy, we need to consider a new approach to our core social institutions, namely industry and government. Industry, in our use of the word, has to do with the methods of production and distribution of goods and services in a society. This includes, of course, labor. The first step, as we have already alluded to, is an objective survey and strategic resource allocation based on location and potential and demand. We have already discussed how such parameters make the process self-evident as you go along and gain new information. The only variable is the value-based social needs, which range from bare necessities, such as food, water, and shelter, to utility-based production items, such as tools, automation machines, technological development, etc., to items used for non-utility-based purposes, such as televisions, radios, and entertainment, leisurely-oriented issues. And by the way, we will address how products are invented in a moment. The second step is then the optimization of production itself, with the focus on maximum efficiency. The only way to achieve maximum efficiency in all sectors is by removing human involvement. And bear with me, removing human involvement in as many areas as possible. We want to focus on labor automation. As most of you know, automation or mechanization has been replacing labor in all sectors continually since the Industrial Revolution. While there is a constant debate about what this means for labor in the future, and the very real possibility that technological displacement, known as technological unemployment, will slowly overcome the integrity of the employment market itself, one thing we do know for sure, and that is the reality that the more we mechanize, the more productive things become. Here is a chart of the G7 advanced industrialized countries, showing how employment and manufacturing has been dropping, while manufacturing output has risen substantially. Productivity is now inverse to employment in most sectors. The most advanced form of mechanization is called cybernation, which combines robotics and computerization. Essentially, the computer is the brain of the machine and instructs the machine what to do. Cybernated machines today are probably the most powerful and influential invention humanity has ever created. The possibilities of these tools are on pace to changing the society in profound ways, including the freeing of the human labor force and exponentially increasing production efficiency. The fact is, there is very little in the way of basic labor that cannot be automated. It is really a simple matter of our social intent. These machines do not need breaks, vacations, insurance, and they are not subject to the emotional inconsistency that we humans tend to fall into that makes us, less consistent in our performance. Here are some examples of this technology. Dynamic catching and holding. My favorite, dribbling. Optical tracking, of course. Throwing. Tweezer manipulation. I like this one, the dynamic catching of a cell phone.